It's Unity again. I'm back, and I've not really done much the last couple of days. It's the real world has been keeping me away from the computer, and I've not had a chance to do a great deal. One of the things I have managed to do is change the texture of the ground, or the roads at least. But it's going to be hard work. I'm under no illusions about the task I'm setting myself here. But I have started to populate the world with a few objects, and as you can see, I'm still struggling with these occasional slowdowns, which are getting a little bit annoying. I thought I'd fixed the problem. I think it's linked to garbage collection, as your software is running in the background. There's a garbage collector tidying up memory, releasing memory that you've previously used for different functions. For example, these objects, as I'm running around the world, the buildings are being destroyed and recreated, and the code will be using variables and arrays and various bits of texture which will no longer be necessary, and the computer has to get rid of it some way, and it uses garbage collection, a system which is called garbage collection, and usually it's pretty it's pretty invisible. You don't really see it, but for some reason I'm hitting these little periods of slowdown. I'm not entirely sure what it's to do with. Here's another one. It might be linked to my save game, because I do. Well, in theory, I have a not a real time. Oh, you see, it just said save thread. So that one was down to a save thread, but the save thread is actually on a parallel thread. Unity doesn't really like, or doesn't allow you to thread your code, meaning you can have two different things running simultaneously. I think Unity is itself highly threaded, and it's available to the developers. You know, they can use different processors for different things, but for the user, you can't really do much threading. This is what I've read, and this is what I understand. You can C# itself, because this is built upon I don't know which version of C# it is, but the C# code itself can be threaded, and as long as you are using objects and data data structures which are within C# and you don't use any of the Unity features such as game objects or whatever, you can actually thread things. So I have actually threaded my save game by stripping out all the Unity elements and just resorting to simple arrays and byte arrays, I think they are mainly. But yeah, so I'm getting these occasional slowdowns. But I am populating the world. None of these things, I mean, I've got a car, but it needs to be textured here. I've got a tree which is roughly textured, some street lights, a few post boxes, some bushes, but they've not got any collision on, although that's a relatively easy thing to get working. I've still got my my unique game, my unique game buildings. This probably won't be one, but it's one that's left over from a very early stage of developing this. Earlier on I actually enabled all the other game elements. You know, I was surprised actually. It looks quite good. It actually looks pretty good. Without all the citizens running around and things happening, it looks less interesting. But we see another one of these slowdowns. I'll have to see whether it's linked to my save game. yeah, starting save thread. So there's obviously something going on. What I did do actually, now I think about it, is I moved my garbage collection to the point of the save game, thinking instead of doing it continually, I would like push it away until the next whatever interval I've got my save game working on, 20 seconds, 30 seconds, perhaps a minute, because I really like the idea of setting myself a challenge of saving a lot of data, which I have done. I compress it quite a lot. A lot of the data is saved in bits rather than bytes, and I've used a byte rather than an integer where I can. So I'm compressing, I'm keeping a lot of my game data small. It works out as a few megabytes, I think, in the end. But yeah, so it is kind of working, but like I say, I have these slowdowns. The thing I wanted to talk about today, I thought I'd try to get back to doing one of these videos on a Monday and not to have too much self-loathing, because I realise that my listening back to myself is terrible, because you kind of hear things about yourself which you never hear, like how often you'll use certain words. So I realised I used the word little too much, or basically too much, or I sniff too much. I'm a terrible sniffer. Don't know why. I try not to tut as much as I did in previous videos. Made me sound like John Shuttleworth. I hate my accent, you know, self-loathing. But anyway, nobody's watching these videos anyway, so doesn't matter. But anyway, what I wanted to talk about today and to show you today was what I did yesterday, which is the trees, which are now being generated procedurally. I know Unity's got a tree system in it. In fact, let's have a quick look at the Unity tree system. I think you basically just do it, create other, is it speed tree or something? What's it called? Tree. So you can add a tree, but it's quite I've not really got into it, to be honest. It doesn't really interest me that much, using somebody else's system. I'm not entirely sure how it works. Oh, there you go. So I think you can add branches to various parts of the tree, and so you can add a branch. Can you move them around? I don't know. Yeah, so it is actually like a tree structure, I think. Yeah, so you can just keep adding branches and whatever, but like I say, it doesn't really interest me that much. I'm much more interested in doing it myself, and it's an interesting programming challenge, I thought. So I sat down yesterday. I actually started this screen recorder software thinking I'd actually log the whole process of writing it, because surely writing a tree system was only going to take 10 minutes, and I could talk through the code I was writing it, and I got to about 10-20 lines and I realised what a horrible job it was going to be, because basically it involves quite a lot of 3D maths, and maths isn't my strongest point. 3D maths I don't know much about, especially when it comes to matrices and 3D transformations and things like that. So what I did is I searched the web, which is always a good source for answers, and found a couple of 3D I tutted, I must stop tutting, some 3D algorithms for rotating objects in 3D space, and I came up with a system which produces, as I hope you can see, trees which are, well, they are random. But within the constraints of a tree-like structure. I should pause this. I think it's having one of those moments of clearing out the memory. Let's find another one. They're all fairly unique. Some look better than the others. I mean, it's one of the great beauties or horrible parts about procedurally generating things is you can produce a tree which looks great and another one which looks lousy. I've not put any foliage on it yet. I'm not entirely sure how I'm going to put foliage on it. at the moment. Even actually the ends of the branches, if you can see, kind of little tubes, so you can actually got some culling going on. You can't see the back of it because the normals are facing outwards, and I've not closed the tips of the branches. I could just make them taper down to nothing, but I've just left them fairly wide. But from a distance, I think it looks okay. And if I can figure out a way of adding foliage which doesn't impact on my draw calls, I'll probably do it. I want my world to be a bit post-apocalyptic. I want it to be a bit of a messy world. That's my ambition. But the trees were a part of it. I was watching for inspiration. I sat down and watched what's that, Will Smith, I Am Legend, based on the Matheson book, which is a brilliant book. It's a less brilliant film, but the production design, the art design was really good in it. I looked at the streets and I like the way the streets have turned into jungle or into forest, and I thought, yeah, I'll add some trees, and I've added a bit of greenery on the floor into the textures. But I was going to add some routines to create bushes and maybe rubble, and try to mess up my city, because one of the problems I have with it at the moment is that I think it just looks too empty and clean, and this is partly why I added holes into the buildings or building textures. But anyway, so here we are. We have procedural trees, and what I thought I would do is quickly talk about the code. Pause the game. Tree generation. Close some of the functions because some of them are self-evident, some of them don't need to be talked through. There we go. So basically, the point of this function is this routine, this method, is to create a mesh for a tree, and the way to do that, obviously, is to do it with a recursive function. A recursive function is a function that calls itself. They can be pretty nasty things, because if you get a bug in a recursive function, the chances are it'll completely crash your app, your program, even crash your PC and have to reboot, because a recursive function is like pointing a camera at itself and filming the results, and you get like one of those long repetitive images of a TV screen which disappears off into infinity. A recursive function can always tend towards infinity if you don't set it up right. The way I've ensured that there's a reasonable endpoint is I'm drawing branches. So I begin with 7 branches. It calls itself, the function calls itself again, but to draw 6 branches, and the 6 branches each will have 5 branches, and the 5 will have 4, and the 4 will have 3. That's kind of how it's working. I think I'll probably reduce it a little bit more than I don't think it's like a 6, 5, 4, 3, 2, 1 situation. Let's have a quick look. So we have one branch which is creating 1, 2, 3, 4, 5. That branch is creating 1, 2, 3, so it looks like I'm reducing it by 2 each time. And that branch there is only producing 2, possibly, maybe 1. So, and then once it hits the end, the recursive functions kind of fall back on themselves, and it falls out of this build branch, and we end up with a nice tree mesh. That function itself, there's a lot of messy code, and I'm not going to describe every line. I'm just going to talk about the general method I took. Basically, each branch has a length, and you iterate through the length. Each part of that length, each small element of, in fact I can probably show it better by looking at the tree. So each branch is made up of 1, 2, 3, 4, 5 segments, which you should see probably at the beginning of my code. Length of trunk is 5. So we're going through 1, 2, 3, 4, 5, and each one of those is made up of a kind of roughly a cylinder of polygons, which I also generate in the code. Segments. There's 8 segments in this particular tree. If you go around, there's probably 8 of them. I could increase the complexity if we change that to, let's say, 15, and try to run it. If it accepts it, there's a chance it won't accept it and it'll crash, but because we will be producing a lot more polygons. Try again. So if we have a look at one of the trees, it says got exactly the same number of segments because I didn't say it. Press save. Unless of course, no, I am looking at the right bit of code there. And now I have one of those really long moments where I have nothing happening. There we go. In Unity, I do find it a good idea to stop running Unity when you run code because it kind of tends to mess things up. Stop. You get all these errors. And once Unity starts to throw errors, your computer slows down until it's finished because it just goes absolutely bonkers. It's one of the things I wish they'd fix in Unity. I wish they'd have some element of restricting the amount of output the console displays on an error, because there's obviously no need to display over 1,000 error messages just because I've changed a bit of code and caused one error that happens repeatedly. Might have to crash out, might have to restart this. No, there we go. Try again. So, our tree should now have nice, more rounded. There we go. Slightly more smoother rounded trunks with a little bit of randomness and bend in it. But like I say, I think it'll look okay. But yeah, so I've split the branches up into these portions and around into these segments. And when I hit the end of it, I generate the number of branches that were called in the function. So there's 7. That's actually reduced it by 2. I think it's producing 5 there, maybe. 1, 2, 3, 4, 5, 6. I must have reduced it by 1. Produces 6, and then the 6 become, that's another create branch routine. That's another create branch routine. Every one of these branches is made up of the identical bit of code, but with different start parameters, such as segments, length of trunk, the base position, and these values here. Well, see here, start angles, 2 start angles, because to achieve rotation in 3D space, you do need to have 2 angles across 2 of the axes. You can do it across 3, I suppose, but it's pointless. You can also do it across X and Y, or Z and Y. It doesn't matter. You'll get the same result, I think. So yeah, what we do is we quickly zip through up the tree, and then each segment is 0 to 360, creating these predefined segment sizes, which is a segment size is 360 degrees by the number of segments, which we changed to 17. So that would be 360 divided by 17. And in here we're just doing the simple vertex creation thing we did in creating the buildings. There's a create polygon routine here, which I'm basically just creating you see my use of the word basically continues despite my vows to stop using it. It's a simple for vector 3s, creating a polygon, defining the triangles, and then creating some simple UVs. I've not bothered really to do anything special with the UV mapping. I'll have to have a think about that. So, create the little tubes of polygons, and then you move. That's basically the heart of the routine. These other parts here, we've got two key sections. I've got that's the bit at the end where we call the recursive function. So we where are we? Oh no, it's here. This is the recursive function that creates the number of branches at the end of the branch. So its branches equals greater than 0 and length is greater than 3. In other words, if they're really, really short branches, I'm not bothering to create them, because, like I say, you're asking for trouble, and it could 3 become 5, 5 become 12, 12 become 20. You know, it's that kind of ridiculous accumulation of recursive functions that I'm trying to avoid. This one here adds a random branch, because if I have just a little number at the end, 4, but I could make it 4,000. It won't spawn random branches up the length of the tree or length of the branches, and it ends up looking quite artificial. So I've included an option to, as we see, it just turns up. It looks tree-ish, but they all look very similar in form. You get like a straight up trunk, and every branch is straight up with branches coming off the end, and each one of those, it looks horribly recursive and obviously computer generated. Not that mine look any less computer generated, but adding a 1 in 4 chance of every segment of the tree throwing off a branch, I think makes it look a little bit more realistic. Hopefully it'll look more realistic when I've figured out how to add some so there you go. That one there has got spawned a branch there and spawned and that one in itself has spawned a little branch coming off, a smaller branch coming off there. So I think it just creates a slightly more tree-like structure. Other little tricks. Well, this code I just took basically off the internet, straight off the internet. It's wrote how to rotate a point in 3D space around the origin. I do all my calculations around the origin to make things easy. And the other difficulty I faced was here, making the branches merge into the base of the tree. What I've done is I've recorded every time I created one of these ring segments, moving up the tree or moving up the length of a branch. I remember the last vertices, the points of the last vertices, so I've got an array which contains that point, that point, that point, that point, every point around there, and then when I call my next segment or my next branch, I pass it to these locations, so it merges the new branch into those points. Previously I had horrible kind of weird gaps and a lack of kind of coherency. Here is one of the problems I have. I don't know why it's doing it. I'm creating some oddly shaped branches. I haven't figured that bit out. I think it might be to do with my rotations, maybe. Doesn't really impact on it a great deal. They look okay. They seem to work fast enough. My code doesn't seem to be getting impacting too much on the speed of the game. I've got to move them around a little bit, add a little bit of rubble, maybe have the odd tree tumble. I've seen some procedural code on the internet which actually have destructible trees. I don't think I'll go to those lengths. Maybe I will. I can't see myself doing that. As much as I would like to have lots of destructible stuff in the game, I don't think it's within my powers at the moment to get it working. But anyway, that's where I'm up to. Come back to the game. It's the trees look okay. They're a bit too they're not lined up correctly because I've not put the code in yet to add any degree of randomness, and but I think we're getting there as long as I can fix this problem with garbage collection, which is driving me crazy. Again, I don't know if anybody's watching these videos, but if you are, hope you enjoy it. If you have any questions, feel free to email me, and hope to do another video soon. Thanks for watching.